Good evening. Today we are going to see the theory part of flanged beam section. So we have two flange section. So we have one as T section and another we have as L section. So we have these two flange sections. So first we will see theory of this. Now we have in this theory we have divided into two types. One, we have neutral axis lies in flange and second neutral axis lies in web. If we will see the T section, then we have T section in this fashion. So we have this as T section. So we have case one if it lies in neutral axis, and second we have that is it lies in web. Sorry, in flange, and second we have neutral axis lies in web. So we have these two types. Now neutral axis in web again is divided into two types. One, df less than or equal to 3/7 XU and df greater than or equal to 3/7 XU. Why we are going to relate with 3/7 XU? So now if we will see, if I will draw flange section, if we will draw SFD, sorry, we will draw a stress diagram. Now you can see in this, df is less than 3/7 XU. So in this case, we are going to be neutral axis larger because 3/7 of XU we are going to say, and that 3/7 of XU we have that is greater than DF. Now I will draw it again. Now you try to understand it because this is most important. Now we have this will be larger one. And my neutral axis will be somewhere here. So we have steel over here. Now if we will plot it, we have in this fashion. Now you can see we have this flange in this, and this is our 3/7 of XU. So as 3/7 of XU greater than DF, so your whole flange, this will be for stress that is 0.4645 FCK, which we have over here. So now in second case, what happens? If I will draw in second case, so we have this as flange and we have web. Now we have neutral axis somewhere here. Now we have DF greater than, means if you will see, then your flange is with both. So you have this flange. So this flange is rectangle also and parabol also. And then it is difficult to go for stress in concrete because it is combination of the two. And in this case, YF is used. And that YF we will see when we will go to this one. So why we are making two separate cases? So try to understand this. When our DF value, this is less than 3/7 XU, our flange is in flange have same stress 0.45 FCK because our rectangular block, the height of rectangular block is greater than flange. But in this height of rectangular block is less than flange, and therefore our concrete do not have same stress that is 0.45 FCK. And as it is not same stress, therefore we have to consider depth that is equal to YF, and that is YF always less than DF. So we will see now in detail. Now neutral axis in flange. So this is very simple. You just read this. When neutral axis in flange, it will be same as singly reinforced section replacing B by BF. Now we will have this as flange section, and we are saying we have neutral axis XU which is lying in flange. And now if we will write XU, so we have to simply use CU is equal to TU, and here CU we have 0.36 FCK XU into BF now, and which is equal to 0.87 FY AST. And from this we will get value of CU, we have this one, XU, we will get this value. And once we know XU, then we have simple, that is CU into lever arm. So same as singly reinforced, change is only we have this as BF. That is only change when our neutral axis in flange. Now, when we have that is neutral axis in web, then in that case DF is less than 3/7 XU. Now just we have seen, so you can see this. So now you can see this DF less than 3/7 XU. If we will draw this diagram, then our whole flange, that is depth is less than this height of rectangular section, and therefore our whole concrete in flange is with 0.45 FCK stress. And now how to find this value of XU? So now we have to go again, that is CU is equal to TU. Now we are going to get two values, that is CU1 plus CU2. Now what we are doing, we have this neutral axis. So this part we are going to divide into two parts. So we have this as rectangular part, and where we will use 0.36 FCK XU into now BW, and then remaining part which is BF minus BW, which is on both sides. So you can see this. So we have this will be CU1. So CU1 word that is related with your rectangular block with width BW. And then we can have CU1 0.36 in the same way. So you can see this 0.36 FCK XU here BW, because we are going to consider this as a rectangular section. Then plus CU2, we have that remaining part which is BF minus BW. You can see this. So this portion we have BF minus BW by 2, BF minus BW by 2. So total we have BF minus BW. And what will be centroid of this? So this is rectangle. So this will be DF by 2. This is total DF. So we are going to get this value, that is DF by 2. And then we have this as DF by 2. So CU2 we will get 0.45 FCK, because overall to all parts we have that is 0.45 FCK, because depth of rectangular is greater than depth of depth of flange. And then we have plus 0.45 FCK BF minus BW into DF, and that is equal to 0.87 FY. Now what will be moment of XU we will get? So XU we can find from this, and that is 0.87 FY AST, and minus this 0.45 FCK BF minus BW goes on this side. So colors I have made, this is for CU2. You can see we have this as CU2, and as this is green CU1, so we have this as CU1. Now XU, so this we will take on this side, so 0.87 FY AST minus, so we have 0.45 FCK BF minus BW upon DF, and divided by XU if we will take, then 0.36 FCK BW. Now moment of resistance, so we have CU1 into D minus 0.42 XU. Now CU we have calculated 0.36 FCK XU BW into D minus 0.42 XU from this. And second we have already seen, we have DF minus DF by 2. So lever arm we will get as G minus DF by 2, because DF by 2 from top, and therefore we will get this as DF by 2. So D minus DF by 2, and that we have mentioned over here, that is D minus DF by 2, and that is shown over here. D minus DF. This part we have already seen, and that we can say that is first part is balancing AST1, and second we have AST2, and just we have to 0.87 FY AST1 and 0.87 FY AST2, and these two lever arm. And then we are with third case, that is DF greater than 3/7 XU. Now in this you can see, if we will go this with the diagram, So you can see this. So now if you will take this line, then you will come to know that your rectangular depth is less than your depth of flange, and therefore our whole concrete is not with 0.45 FCK, and I is given a term, so that is YF, so that we will see. Now we will have this as CU1, and that is same as we have last. Now second we have this is YF. So as concrete is not going to be, depth of flange is not going to be greater than this depth of rectangular portion. So we are going to consider equivalent depth. This is given in IS 456, which is YF, and we are considering equivalent depth of flange having value that is equal to 0.45 FCK stress. So now in YF equivalent flange, we have stress is 0.45 FCK, and that is given by IS code, so which is 0.15 XU plus 0.65 DF. And that we are going to use. Now we have second part CU2 instead of DF in last case. Now we have YF. So you can see this. So we have same, no change. So 0.45 FCK BF minus BW into YF, and that is equal to 0.87 FYEST. So we have only changed DF by YF. Other things we have as it is, no change is there. Now here also we have D minus 0.42 XU first as it is in second. So now you can have this as YF, and so this we are going to get at center of this YF by 2, and you will get lever arm. So this lever arm is D minus YF by 2. And likewise, we are in position to get moment of resistance. And then AST1 already I mentioned this, because CU1 equal to TU1 and CU2 equal to TU2, we will get this value. So these are the theory portion which is related with your flange section. Now this we can have this 0.36 FCK XU BW. So now I have substituted these values of YF as 0.15 XU plus 0.65 DF equal to 0.87 FYEST. And then to find XU, we have made these terms separate. We have multiplied this with 0.15 XU, you can see, and here that is with 0.65 DF. And to find XU from first term and second term, we have taken XU common, and this 0.45 FCK we will take on right side, and that will be 0.87 FYEST minus 0.45 FCK BF minus BW 0.65 DF, and that is this value we have below. And then from this we will get XU value. So we will stop here only. So thank you. This is about your theory part of flange section. So thank you.